Okay, the last piece in your notes, it's factor completely. Factor completely is just telling you to factor using any method possible. So we've gone over factoring using the GCF, factoring difference of squares, sum and difference of cubes, trinomials, and grouping. You have to distinguish which one you're going to use now. So first things first, we are going to cross out all of these right here, all of them. We're not going to do any of these. So we're really only going to go over these 4. Okay, so number 25. We've got 2 terms. So when we have 2 terms, you know it's not going to be using the trinomial piece. You know it's not going to be factored by grouping. So that means it's going to be one of these. Well, it's either going to be difference of squares or difference of cubes, or neither of them at all. Now this is an n to the 5th, and an n, a 5, and a 180. Those aren't perfect squares or perfect cubes, so it must just be factoring out a greatest common factor. So let's factor out that greatest common factor. Between 5 and 180, it has a factor of 5 in common. N to the 5th and n, it has a factor of n in common. 5n times what gives you 5n to the 5th? That's n to the 4th. Bring down your minus. 5n times what gives you 180n? 5 times 36. Normally you would say, okay, I'm done. I factored out the GCF, but we got to look at this right here. Can this be factored? This is a difference of squares. Perfect square, 36. Remember, this is also a perfect square. So this is going to change into something like this. So remember, n to the 4th minus 36. We got x squared minus y squared equals x plus y times x minus y. This is your x squared, this is your y squared. So if x squared equals n to the 4th, that means x is equal n squared. If y squared is equal to 36, that means y is equal to 6. Remember, you just take the square root of both sides, skipping that step. So therefore, what goes here is x plus y, which is n squared plus 6, and then n squared minus 6. That is your answer now. So you really had to factor twice to be able to factor this completely. Okay, number 27. Let me see how much time we got on this. Okay, number 27. So we have 3 terms. The first thing you need to do each time, it says right here, always check to make sure you can get a GCF first before you do anything else. Well, it looks like we have no j's in common in all 3 terms, but we do have a k in common in all 3 terms. So let's factor out a k. Once I factor out a k, I'm left with j to the 4th plus factor out a k, 3j squared, factor out a k, minus 28. All right, so we've got 3 terms. That's a trinomial. Let's see if we can factor this using the method with the x. Okay, so the method with the x. We got 1 times negative 28 is negative 28. Middle number goes here. 1 times 28, 2 times 14, 3, 4, 4 times 7, and that's the last one. How can we get a 3 out of this? 7 minus 4. So we got k, we're going to do j minus 4, j plus 7, right? Negative 4 plus 7. Wait a second, remember, when I multiply this, I'm supposed to get this right here. J times j is what? J squared. It says j to the 4th, so that means we need to put squares here. Now we are finished. All right, let's go and do number 29. All right, number 29, we've got a c cubed in 2 terms. So right away you should think it's probably a cube. So it's probably either going to be sum of cubes or difference of cubes. Is 27 a perfect cube? Mm-hmm. Is 8 a perfect cube? Yes. So we're going to use the equation x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. So what we need to do is figure out what is x and what is y. Well, x cubed is equal to negative 27c cubed. So we need to cube root both of them. All right, so the cube root of x cubed is x, and the cubed root of negative 27c cubed is negative 3c. You can take a cube root of a negative. All right, now we got y cubed is equal to 8. Cube root both sides. This is going to be y is equal to 2. Now you get to just plug and chug. I'm not going to go through that part for the sake of time. So you would just plug and chug. Please fill that out before you turn it in tomorrow and before I check your notes. So fill out the rest right here. Okay, last but not least, number 31. Once again, it's two terms. So it's either going to be difference of squares or difference of cubes. So let's look. Is 9 a square or a cube? It is a square. And 576 is also a square. So, oh, what did I forget to do? I forgot to check my GCF first. So that was my problem. So between 9 and 576, we actually do have a factor of 9 in common. If I factor out a 9, I'm left with y to the 6 minus. So 9 times what gives me 576? That is 64. Okay. So next what I would do is I'm seeing either a difference of cubes or a difference of squares. So I'm going to look at my notes. 64 is actually in both of them. So let's do difference of squares. So if I did difference of squares, this would be y squared plus 8, y squared minus 8. And that would be our final answer. Ooh, not y squared, not y squared, y cubed. Y, oh, no, Okay, so that is not a perfect square. We have to do a cube. So this is a perfect cube. So that means this is x cubed and y cubed. So that means that x cubed is equal to y to the 6th, which means x is equal to y squared. And y cubed is equal to 64, which means y is equal to 4. Plug it into this formula. X minus y, x squared, plus xy, plus y squared. So we've got x equals y squared, that's going to go in the x spot, and y equals 4. Go ahead and fill out the rest here. Sorry about the mistake earlier, but this is a difference of cubes. So your final answer is going to look like this. Binomial, trinomial.